Very good evening, all of you. Welcome to Unacademy. Welcome to Creatics channel. So let's start the session. Are you ready? Okay, let's start the session. So welcome to the session. Welcome to Sankal Patch Gate 2023. So today we are going to start the marathon series on second order circuits of network analysis. आज हम तो network analysis में second order circuits discuss कर रहा हूँ. Second order circuits में we will be dealing with the LC circuits and RLC circuits. Not only that, we will be discussing some special case problems also. Special case of transients we will be discussing in this. Okay, so let's start the session. Very good evening once again to all of you. So, let me start the session. So, let me introduce myself. This is Bhima Sankar. I did my Mtech from IIT Kharagpur. I have 10 years of teaching experience, more than 10 years in the last 11 years. I have been teaching to many students like you people and guided many students to reach their destination. So, I have, uh, I covered almost all corners of the country in the last 11 years. So, with my experience, I'll be giving you the best possible content or guidance, whatever you are expecting from me. So, generally, I deal with the following subjects: networks, digital control, analog circuits, and computer animation, microprocessor. So, let's start. सो पहले सेशन को शुरू करने के पहले मैं आपको एक इन्फॉर्म करना चाहिए एक इम्पोर्टेंट अपडेट. सो अभी तो गेट एग्जाम तो वेरी नियर. सो आपके लिए गेट एग्जाम के लिए ऑल इंडिया मॉक टेस्ट सीरीज इज रेडी फॉर यू विथ अन अकेडमी गाइस. आपको ऑल इंडिया रैंक मिलेगा इस पे. सो आप लोग क्या करना चाहिए? See here, enroll to this link is will be available in this video description. You can use my code and enroll to this exam. This is going to happen on this Sunday and all the Sundays coming up to your GATE examination. चलो. So आज actually मैं तो शुरू करने के लिए start, I mean 4 o'clock I was ready, but there is some power cut. I'm not able to start the class on time. So आपको an academy का सब्सक्रिप्शन लेना चाहिए तो आप EMI पे ले सकते हैं. All you need to do is just call to this number. You get the approval of the loan and you can pay every single month. So आपका अकेडमी का notes भी available है अभी. So if you take the iconic subscription, so the new batch has started 2 days back for 2024 aspirants. So all these are the USPs of this particular batch. So let's start the session. So second order circuits and special case of transient. Okay. Last week we are dealing with RL circuits, RC circuits. RLC we haven't touched, right? So today's session we will be dealing with what we call LC circuits, RLC circuits. I mean it's performance analysis under various conditions, how to solve the network of second order systems. And इसके अलावा we also deal with some special case of the problems in the transient. What are those special case? Sometimes if pulse is given as input to the circuit, if DC input is given, you know how to solve the transient network. If pulse is given as the input, what to do? If the network contains multiple switches, not a single switch, in that condition, in that case, what to do? Or if what we call if your network is having what we call voltage source in parallel, see current source in the series, different special cases are available. All those conditions we will be solving today. So not only the second order circuits, we'll also solve the questions which are little difficult or little tricky in the transient part. Those questions we are going to solve today. Chalo, let's start. So firstly, let's do the analysis of RLC, then we do the analysis of the LC circuit also. Right, so first we do analysis of the LC first. Say I have a capacitor with initial voltage V0 in series with a capacitance. Okay, and also I have an inductor. For simplicity, I am not taking any initial value for the inductor. Now they are connected like this. It's a pure LC circuit. People will call it a tank circuit also. So this is your voltage across the combination, and this is the current flowing in the network. Okay, I have taken the network in the Laplace domain, capacitor with some initial voltage V0. Good evening, Anshul. How are you? Okay, capacitor with some initial voltage V0. Okay, so what is I of S? Initial voltage V0 by S. Initially, little theory I will give, then we will do necessary problems. Okay, this is the current IS. So I can write CV naught by S square LC plus 1. Okay, take S in the numerator, SS cancels and this one. So now I can take LC common in the numerator, that will give me V naught by L S square plus 1 by LC. I want to write this in my required format. मेरा required format तो Laplace transform inversion करने के लिए आसान होने वाला format में लेना चाहिए. So if you take in a format which is convenient for you, just multiply this with V naught by L with root LC into 1 by root LC by S square plus 1 by root LC whole square. So what do you get here? V naught into root of I'll be getting it root C by L. What is the inverse Laplace transform of this? You can comment. A by S square plus A square or omega n by S square plus omega n square. What is the inverse Laplace transform of A by S square plus A square or omega n by S square plus omega n square? It is sine omega nt, where omega n is 1 by root LC. Okay. So that is about your current response, which is sinusoidal in a pure LC circuit with some initial energy. What happens is inductor and a capacitor will be exchanging the energy between them. So inductor की energy capacitor को देती है, capacitor की energy inductor को देती है. That happens in the resonance, which you study later. So because of exchange of energy between them, when there is no resistor present, it will generate undamped oscillations up to infinite amount of time, ideally, but not practically. Ideally, this is what happens. So it is easy to remember in this format. That's why I have given as omega n instead of writing 1 by root LC. Now, what is V of S? I of S into SL. Because this current into this impedance will give me the voltage, right? So here SL into V naught by L S square plus 1 by LC. This can be written as V naught into S by S square plus 1 by root LC whole square is my V of S. So what is V of T here? It is easy to remember. V naught cos omega. Okay. So the conclusion here, इस वाला सर्क्यूट में I of t इक्वल टू V नॉट रूट C by L sin omega nt. Voltage will be V naught, where V naught is the initial voltage across the capacitor, cos omega nt for t greater than equal to 0. Okay, what is the value of omega n? 1 by root L. So this is the question. Okay, this is the information about the LC circuit. Now we will discuss RLC circuit also. Then we will move for few problems. Then I'll come back and I'll explain some special cases also. Right? Chalo. Right. See, just a moment. So let's try a question based on this. Before going further theory, let me do a question. This question is very good question here. Please don't miss this. Please give a try. Just a moment. first to do this part, figure shows the current flowing through the capacitor of 0.3 nanofarad. Find the charge stored up to what we call 5 microseconds. This is the waveform with the time is in microseconds and current is in milliampere. You need to find the charge acquired or stored by the capacitor up to first 5 microseconds. So please give a try and tell me the answer. Okay, we have a lot more things to do, guys. Many good questions are waiting for you. These many things we are going to do today, but let's do this first because after this I'll touch one LC part. Okay, this is the foundation or basic part of that question. It is not the original question. First, let's start with this. So please give a try and tell me the answer. I'm just waiting for a few more seconds. I'll wait and I'll be doing the question. So if you are able to do it, please give a try and tell me the answer. ये question तो आसान है, इसमें कोई दिक्कत ही नहीं है ना. So it's not much difficult. You people can do it, I hope. So what is the solution? ओके, करंट I इज इक्वल टू डी क्यू बाई डी टी. आपको भी पता है आपका Q क्या होता है सर? इंटीग्रेशन ऑफ आई डी टी. सो इंटीग्रेशन का मतलब क्या होता है सर? एरिया अंडर इट अप टू वन. व्हाट इज दैट? इंटीग्रेशन इज नथिंग बट द एरिया. सो आप एरिया निकालो. दिस इज वन ट्रायंगल up to 5 na. This is another triangle and one rectangle. So what is the area of the triangle? Half base height. Again, this triangle, half, what is the base from 2 to 5? 3. Height from 2 to 4? 2. Rectangle 2 to 5, it is 3 into 2. So here it will be 4 plus 3 plus 6. What is the answer? 13. Here time is in microseconds, current is in milliampere, so the charge will be in 13 nano coulomb. So up to this question is clear to everybody. Please respond, please comment. Very good. 13 coulomb to nahi hai bhai, 13 nano coulomb. Okay, because the time is in microseconds and current is in milliampere, so it is 13 nano coulomb. So is it clear up to this? क्लियर है ना? चलो, अब एनर्जी निकलने समय पे, ओके, which part it is charging, which part it is discharging, we need to find. In that case, see here, that's a different case. If you suppose, if you want to find the final energy at this node, suppose at this node what is energy of C4 square. Here what is energy of C2 square. So इस समय पे it is discharging. That is while calculating the energy, we will find this part. Okay. Here area तो नेगेटिव नहीं है ना, नीचे तो नहीं गया, नीचे गया तो हम नेगेटिव लेते हैं, ठीक है. बट एनर्जी का समय पे इफ यू टेक हियर, एनर्जी का समय पे क्या होता है सर? E इक्वल टू इंटीग्रेशन ऑफ V इंटू आई डी टी ना. इस समय पे दिस नेगेटिव स्लोप मैटर्स, करंट इज नेगेटिव. ओके, राइट, लेट्स मूव. सो 13 नैनो कूलम तक चार्ज होने कैपेसिटर जो है ना, अभी क्या करते हैं? लेट अस सी. The capacitor with initial charge calculated is connected. This question, please give it try. Connected across. It is connected across uh, the inductor of 0.6 millihenry. Find voltage across capacitor at time t equal to 1 microsecond. Yeah, this is your part, guys. Please give it try and tell me the answer. मैं तो आपको ऑप्शंस दे रहा हूँ. So please give a try and tell me the answer. Already I have given some what we call just theory or theoretical explanation for this particular question. So हम तो क्या किया, firstly capacitor को charge किया. This is a linked question given in one of the previous papers. So capacitor को initially हमने charge किया. Okay. So and what happens is we have charged the capacitor with how much? 13 nanocoulombs. Now the capacitor is removed as the capacitor is now connected across inductor of how much? 0.6 millihenry. And now what happens is this 0.6 millihenry inductor and the capacitor are connected in parallel. Now what we need to have, what happens, you know that already I explained, exchange of energy between them. So examiner का question तो ये है, what is the voltage across the combination at a time t equal to exactly 1 microsecond. Exactly 1 microseconds में what is the voltage across the combination. No answer? Mostly no answer matches, but there is an answer. Okay, most of the people might have tried this question and solved it and feel that अरे यार गलत options दिया sir ने. Okay, I have given the right options only. आप लोग थोड़ा सा सोच के देना चाहिए आंसर, थोड़ा सा बेसिक सही से करना चाहिए. वैल्यू ऑफ द सी तो 3 नैनोफैरड और 0.3 नैनोफैरड ना. सी का वैल्यू कितना? 0.3 नैनोफैरड. सी का वैल्यू तो, सो व्हाट इज द फॉर्मूला हियर? डायरेक्ट फॉर्मूला तो है ना हमारे पास, आज अभी हमने डिस्कस किया इसके बारे में. व्हाट इज द फॉर्मूला फॉर v ऑफ t? v नॉट cos ओमेगा mt. कैलकुलेशन वाला पार्टी है भाई. सो v नॉट तो कैलकुलेट करो आपने. v नॉट कितना आती है भाई? v नॉट इज इक्वल टू q इक्वल टू cv. सो v इक्वल टू q बाई c. q कितना आया आपको? 13 नैनो कूलम by capacitor का value 0.3 nanofarad. So this will give me 13 by 0.3. 43.3. This is the V naught value. So omega n is 1 by root LC. So what is this value? L. C. C value कितना? That will give me omega n. Can you calculate this? Two point 357 into 10 power 6. So what is V of t, sir? V naught, 43.3. Okay, cos omega is 2.357 into 10. This is the answer. Okay, fine. This is the answer, undoubtedly correct. Now examiner को कहाँ पे चाहिए भाई V of t? कहाँ पे चाहिए V of t? V of t is required at the time t equal to 1 microsecond. So it will be 43.3 cos omega n t. So you may think, sorry, 43.3 cos 2.357. So what is cos 2.357? Let me calculate that. 2.357, 0.99 RL. So that will give me 43.2. Sir, but no option matches with 43.2. So where is the mistake? Where is the mistake? Please kindly respond, guys. Where is the mistake? कहाँ पे किया गलत? मेरे को आंसर आ रहा है 43.2, बट एक ही ऑप्शन भी नहीं मैच हो रहा है ना 43.2, तो ऑप्शन तुम पे नहीं है. क्यों ऐसा क्यों हुआ? हम तो सारे क्वेश्चन तो सही से किया, एवरी सिंगल स्टेप अब तो अच्छी से फॉलो किया. सो वेयर इज द मिस्टेक? प्लीज टेल मी. या वर्मा तो वर्मा को भी आया सेम आंसर 43.2, बट ये तो गलत है. एनीबॉडी हियर इन द क्लास हु कैन से व्हाई इट इज रॉन्ग? कहाँ पे गलत किया हमने? टेल मी, कहाँ पे गलत किया? एनीबॉडी? If nobody, then I can solve it. I'll solve it. No idea? Come on, give it a try. नो, वोल्टेज अक्रॉस इंडक्टर के पास तो सेम ही होता है भाई. गलत. एनी अदर आंसर बाय एनीबॉडी? एनी सम गुड आंसर? 9? अरे यार आप लोग, हम तो डिराइव भी किया ना. Come on. So I will explain here that mistake कहाँ पे किया. This must be in radians, but not degrees. ये costly mistake होता है. ठीक है, डिग्रीज पे लेके आपने क्वेश्चन किया. So V of t equal to 43.3 cos 2.37357. How to convert radians into degrees? How to convert radians into degrees? 180 by 5. Now try. So this will give me 135.046. So 43.3 into minus 0.707. So that will give me minus 30 point, approximately minus 30 points. Okay. So this is small simple mistake. When you are relating with the time, angle must be in the radians. Be careful with that. एक छोटी सी mistake आपका पूरा marks ले सकते हैं. Right? Now it is fine. Very good. GATE aspirant. रेडियन और डिग्री है तो डिग्री होता है, ऐसा रेडियन होता है, हम डिग्री पे कन्वर्ट करके करना है. अराउंड अप्रोक्सीमेटली बोल रहा हूँ मैंने ऑप्शंस को मैच करने के लिए. मे बी इट इज 30.4 समथिंग आ सकते. सो नाउ इट इज क्लियर. इट्स अ वंडरफुल क्वेश्चन यार, गिवन इन वन ऑफ द प्रीवियस पेपर. राइट, एलसी वाला बात तो हो गया, इस वाला क्वेश्चन तो हो गया. सो लेट्स गो बैक and do some theory, then come back to the all questions. Okay, as many questions as possible. Okay, next one, RLC circuit ka analysis. So let's do some analysis of the RLC circuits, and we may do few questions based on this. So let's start. So let's take a series RLC circuit. ठीक है. So मेरा पास एक series RLC circuit है. Okay, इस पे क्या होता है सर? This is the RLC circuit basically. To get the natural response of the RLC circuit, what is V of t equal to voltage across resistor, inductor, capacitor. ठीक है, if you take a RLC circuit. Okay, so just a minute. Swami Saran, thank you Mahi. So let's continue just a moment. Right. So in this case, आपका v of t का इक्वेशन क्या I into r vl तो l di by dt vc तो क्या होता है सर 1 by c integral I dt. So if you take this v as a dv by dt and assume there is no input or the input is dc, इस केस में r transient response लेना चाहिए, आपका input तो नहीं है, इस केस में क्या होता है सर, मेरा r into di by dt l into d square by dt square of I of t and I of t by c. Okay, this is the second order differential equation. So that's why we call these circuits as second order circuits. It should have two memory elements. It can be two capacitors also which are not separable. Okay, generally if you have a multiple capacitor circuit also, it can be a first order circuit only when all capacitors are considered into a single part where you can find the equivalent in that particular case. But इस case में क्या होता है sir? इस case में क्या होता है sir? Here you cannot separate or you cannot converge this equation into a first order case. This is the second order differential equation. The same happens if you have a LC circuit also. Now see here, right? You can try this solution, differential equation ka solution with the help of Laplace. SR plus S square L plus 1 by C into I of S. So ये वाला part I of S जो होता है, generally I equal to, you may take here V by Z and that denominator if you make it equal to 0, that is directly you can do Z of S equal to 0 also, R plus SL plus 1 by SC को भी 0 कर सकते, then you get the characteristic equation of the system. थोड़ा सा इसको हमारे रिक्वायर्ड फॉर्मेट में लिखना चाहिए, सो इसके लिए L कॉमन ले रहा हूं मैंने, S स्क्वायर प्लस S इंटू R by L plus 1 by LC equal to 0. This is my final expression. Okay. Now let's compare. Let's compare this with what we call. Let's compare this equation with what we call the standard equation which you study in your control systems also of the second order system. S square plus 2 zeta omega ns plus omega n square. ठीक है, राइट. सो आप ही बताओ इसमें ओमेगा एन कितना, 1 by root L. नेक्स्ट, व्हाट इज 2 जीटा ओमेगा एन, R by L. जीटा क्या, R by 2L omega n, R into root LC by 2L. So R by 2 root of C by. I'll take it to the next page, but right, these are the concluding points. Maybe it is not visible, don't worry. So here आपका जीटा तो R by 2 root of C by L and omega n is 1 by root LC. So final conclusion क्या, जीटा is equal to R by 2 root of C by N. ठीक है, ओमेगा n equal to 1 by root LC. Okay. So now what happens is, based on the zeta, we define the response, the damping condition of the response. Means generally what happens is, these oscillations which you are expecting, that is inductor capacitor को energy देती है and capacitor inductor को energy देते हैं, ये continuous process जो होता है ना, this should happen up to infinite amount of time if resistor is not present. बट अगर मेरा रेजिस्टर आएंगे तो फील्ड पे, रेजिस्टर आएंगे तो क्या करते हैं भाई, इंडक्टर के पास तो क्या, दे डोंट डिसिपेट द एनर्जी, दे जस्ट स्टोर द एनर्जी. बट रेजिस्टर कम्स इनटू द पिक्चर, it will be dissipating the energy. So inductor is giving the energy to the capacitor. In this process, resistor eats some energy. So every cycle में inductor gives the energy to the capacitor, capacitor gives energy to the inductor. In between, this resistor is taking some energy, so it is losing some energy. So every single cycle, if it is losing some energy, the oscillation का size will be decreased. So let me show you that with some simple example. ठीक है, आप एक simple pendulum का example ले लो. चलो, देखो एक सिंपल पेंडुलम से I mean, this is the mean position. यही से मैं छोड़ दिया. Then what happens is ideally it should oscillate like this. ये तो ऐसा oscillate करना चाहिए about its mean position. Ideally, it should oscillate up to infinite amount of time, like this, like this. It should oscillate up to infinite amount of time when there is no opposition. But suppose there is some opposition. अगर some opposition आएंगे तो it should overcome this opposition, come back. Overcome this opposition, come back. So to overcome this opposition, it is losing some energy, losing some energy, losing some energy, and it will come to rest after some x amount of time. The same happens when you have pure inductor and capacitor. What they will do is they will be exchanging energy to with each other, ideally up to infinite amount of time without any damping. We call this as undamped oscillatory condition. But what happens when resistor comes into picture? Every time in every cycle it is losing some energy, and over a period of time your oscillations will die down. How they are dying down is given by the damping factor zeta, that will tell you whether they are going exponentially, they are exponentially and multiplied with sine or ramp, whatever maybe. How they are going to die is given by r value. That r value is indirectly related to zeta. Okay, that we are going to discuss now. Just I'll give concluding way, not in a comprehensive way which takes more time to explanation. Okay, because this is a marathon session, our main intention is the problem. So you can understand, inductor capacitors are like sisters, they are eating some food, but inductor is a sister giving to capacitor. Capacitor is not eating, giving to inductor. This is a continuous exchange process. But meanwhile, one brother came resistor. He said, I will share your food. Okay, he is eating the food in every single cycle, and the food will is going to die. The same happens when capacitor or inductor is having some initial energy. They don't eat, they will be just exchanging. But resistor comes into picture, this will die down to zero. Chalo. So first condition, zeta equal to r by 2 root of c by l, and omega n equal to 1 by root lc. First condition, when zeta equal to 0, my r equal to 0. ठीक है, अगर रेजिस्टेंस नहीं है तो देन जीटा इज इक्वल टू 0. इसको बोलते हैं अनडैम्प्ड ऑसिलेटरी रेस्पॉन्स. So undamped case में your poles and zeros, the poles will be located on the imaginary axis, because इस क्वेश्चन पे इस पे जीटा 0 है तो s स्क्वायर प्लस ओमेगा n स्क्वायर इक्वल टू 0. रूट क्या होता है? s इक्वल टू प्लस आर माइनस जे ओमेगा. यही पे होता है आपका रूट. नेक्स्ट कंडीशन, आपका जीटा का वैल्यू 0 से कम ज्यादा बट 1 से कम है तो आपको रिक्वायर्ड कंडीशन ये इससे 1 से कम होना चाहिए. दैट इज r स्क्वायर बाय 4 शुड बी लेस देन l बाय c. इस केस में क्या होता है सर? आपका रूट्स विल मूव फ्रॉम दिस पोजीशन टू दिस पोजीशन. यू विल बी गेटिंग इट, and this node is minus zeta omega. That is the real part of the total complex pole. Okay, you have a complex pole. I'm not going deep because here it is omega d hota hai. Okay, zeta into 1 minus omega n square. All this story I'm not going through it. Okay, because in control systems anyway you will be studying this. Okay, this case may what is your response is you will be getting the response which is dying down. Okay, it is a multiplication of exponential signal and sinusoidal signal. E power minus zeta pi t root of 1 minus zeta square sine omega dt, which you study in the control systems, that happens. It will be a multiplication of exponential and sine. Okay, so the oscillations will die down over a period of time. And in this case, generally LC's RL circuit में time constant I have explained L by R, RC में R into C. For RLC here, what is the time constant is 1 by zeta omega n. If you have e power minus 80, 1 by a will become your time constant. That much simple. Okay. Next. Zeta equal to 1. R will be, or R square by 4 equal to L by C. Or R will be 2 times root of L by C. This is called critical resistance. That is the resistance required for the critically damped condition. Here the poles are real and equal. You have the poles here at omega n. So if you make here zeta equal to 1, a square plus b square plus 2ab format aayega, a plus b whole square. What is the inverse Laplace transform of 1 by s plus omega n whole square will be? It is some constant into t e power minus omega n. It is a multiplication of ramp signal and exponential signal. And the last condition is greater than 1, where r square by 4 is greater than L by C. Okay, here you get the response as sum of two exponential signals. Because 1 by s plus a, 1 by s plus b आएगा आपको. So e power minus omega 1t and omega 2t, you will be getting it. And इसको बोलते हैं over damp. Here your poles will be real and different. Here, the pole which is nearer to the origin is called critically damped, and time constant is defined by the first pole. Okay, mostly you will be getting this sort of response. You see here, why first pole is required? Because P1 is less than P2, 1 by P1 will be more than 1 by P2. So by the time 5 times 1 by P1 is always greater than 5 times 1 by P2. So whichever takes more time, that we need to consider. Okay, so this is the condition. Here to आपका tau 1 by omega n. Here tau तो नहीं होता है because it is a continuous process. Up to infinite amount of time, they will be exchanging their energy. So this is called critical damp. And this is what we call under damped condition. Same analysis you can do at your home for parallel also. So that is a little analysis of the RLC circuits. Okay, under second order circuit. So special case possible hai to I'll deal it. Firstly, let's do RLC and LC circuits. So these are the RLC and the LC circuit analysis. So मैं तो LC में already बताया ना. It is proved also. You are getting the responses है sinusoidal pure oscillatory response आएगा आपको. So this is about your LC and RLC analysis. Most any case when you have a problem or circuit with LC circuit or RLC circuit, हमेशा हम कैसा डील करना चाहिए, कोई भी LC और RLC सर्किट को डील करना चाहिए तो हमेशा हमेशा हम लैपलेस से डील किया तो काम आसान होता है, क्योंकि because it is a second order differential equation, it will take it will be easy if you go by Laplace. Chalo, let's do few questions before going for the special cases and all. Yeah, you can try this question. Give a try, read this question. Maybe reading itself will take more time. First read. I'll pass. Yes. Now read the reading is done. Now try the question. Fourteen seconds more. Okay, very good, correct. चलो, this is the current I of t. Okay. So in the network shown in the figure, power consumed by the resistor remains unchanged at the time of switching. ठीक है, ओके छोड़ दो ये वाला नेटवर्क जो है ना, ये स्विच तो पोजीशन चेंज किया t इक्वल टू 0 पे ए से बी, उस वाला समय पे इट रिमाइंस अनचेंज्ड एट द टाइम ऑफ स्विचिंग. डिटरमाइन द वैल्यू ऑफ द करंट IM. सो आप IM का वैल्यू निकालना चाहिए. क्वेश्चन तो कंप्लीट नहीं, प्लीज रीड दिस कंप्लीटली. ये है दिक्कत, आप यही तक यू रीड इट. अरे IM नहीं है, क्वेश्चन तो इनकम्प्लीट है, छोड़ सकते क्या? So read it properly. So and find the element x. What is I of t given by examiner? I of t equal to Im sin omega t plus phi, where phi equal to 30 degrees up to time t equal to 0. So first and foremost understanding, when the switch is at this position, there are two elements, L, and the other element can be resistor or capacitor. So these two elements are RL circuit or LC circuit. अगर RL सर्क्यूट है तो रेस्पॉन्स क्या हो सकते हैं, LC है तो क्या हो सकते हैं, आपको पता है. RL पे रेस्पॉन्स इज एक्सपोनेंशियली डिकेइंग, LC पे रेस्पॉन्स इज ऑसिलेटरी. LC पे रेस्पॉन्स इज ऑसिलेटरी. ओके, सो you see here, Im sin omega t plus phi, it is a sinusoidal response. So LC circuit दिया. Okay, it is not RL. Definitely, oscillations can occur only when you have both inductor and capacitor. So the element X must be compulsory capacitor. This one you have accepted or not? Because it is a RL circuit है तो आपका response exponential होना चाहिए, but the response is oscillatory. So I can say this response is oscillatory. Oscillatory response means capacitor for sure. So resistor वाला options तो निकाल दो. दो ऑप्शंस है करंट के लिए, आई मीन रेजिस्टर वाला ऑप्शंस तो निकाल दो, कैपेसिटर वाला ऑप्शंस तो वी नीड टू कीप, रखना चाहिए भाई. 4 एम्पियर 2 एम्पियर में एक आपका आंसर होता है. सो लेट्स डू दिस. सो फर्स्टली एट टाइम t इक्वल टू 0 माइनस, जस्ट 0 के पहले. ओके, सर्क्यूट कंडीशन इज लाइक दिस. या switch is at this position, you have an inductor and the element X. Okay, and this is I of 0 minus L. Okay, fine. 1 ampere. Firstly, can you tell me? Here I don't take inductor in short circuit network in steady state because LC में it's a continuous process of exchanging of energy between them. So don't take them in the steady state condition. So here, what is your I of t? Im sin omega t plus 30 degrees. So what is I of 0 minus Im sin 30 degrees? That will be Im by 2. Inductor current cannot change instantaneously. So I of 0 plus is also 30 degrees ले सकते क्या? Sorry, Im by 2 ले सकते क्या? Yes. And now this current is 1 ampere. What is the power consumed by the resistor PR of 0 minus? Power consumed by the resistor just before 0, I square R. That is R watt. As per examiner, at the time of switching, the power consumed by the resistor remains unchanged. In this question only, not every time, but as per examiner, in this case, it happened. So what is PR of 0 plus? Same. Now, let's draw the circuit at time t equal to 0 plus. 0 plus में क्या हुआ? मेरा 1 ampere as it is रखा, मेरा resistor जी as it is है भाई. एंड नाउ मेरा स्विच तो मूव किया मैंने इस लोकेशन को. ओके, सो इस लोकेशन पे इंडक्टर है ना, and the immediately after the switching action, as the inductor current cannot change instantaneously, मेरा इंडक्टर कैसा काम करेगा भाई, ये तो ओपन सर्क्यूट जैसा काम करेगा विद द इनिशियल करंट इन पैरेलल. इक्विवेलेंट सर्क्यूट्स में हमने डिस्कस किया, दिस इज द इनिशियल करंट इन द इंडक्टर Im/2 पैरेलल विद द ओपन सर्क्यूट आफ्टर द स्विचिंग एक्शन. जैसा मेरा स्विच यही से यही पे मूव किया तो कैपेसिटर इज आइसोलेटेड. ओके, सो नाउ सी हियर, this is the condition. Now let's take this current IR. Now, firstly, what is power in the resistor at time t equal to 0 plus R watt होना चाहिए. W is watts. Okay, so that is IR of 0 plus into R equal to R. So आपका IR कितना होना चाहिए? Time t equal to 0 plus, ये तो 1, ये तो 1 होना चाहिए. Listen, now at this node 1 is entering, Im/2 is leaving. So KCL क्या होता है सर? 1 equal to IR of 0 plus Im/2. Okay. So आपका IR of 0 plus कितना होता है सर? 1 minus Im/2. So substitute this equal to 1 minus Im/2. Then 1 cancels. आपका Im कितना होता है सर? 0. ये तो गलत आंसर है. अगर 0 है तो 0 साइन ओमेगा टी का कोई मीनिंग ही नहीं है ना. So how is it possible without making Im 0 but power तो सेम होना चाहिए? So क्या करना बताओ भाई, कोई गलत किया मैंने? Tell me please. यस सर, एग्जामिनर ने ये बताया पावर सेम. पावर सेम का मतलब करंट का मैग्नीट्यूड सेम होना चाहिए, डायरेक्शन उल्टा भी हो सकते ना. सो करंट आगे से नीचे जा सकते हैं और नीचे से आगे भी. आगे से नीचे जाने समय पे भी करंट तो 1 एम्पियर और नीचे से आगे जाने वाले 1 तो भी पावर विल बी सेम. सो हियर आप ये करना चाहिए, IR स्क्वायर ऑफ 0 प्लस इक्वल टू 1. दैट इज आपका IR तो प्लस आर माइनस 1 लेना चाहिए. ठीक है, सो प्लस 1 ले लिया तो गलत हो गया. नाउ यू टेक द माइनस एंड सॉल्व द क्वेश्चन. ओके, IM will be 4. दैट्स ऑल. सो थोड़ा सा लॉजिक हमने अप्लाई करना चाहिए. 2 पॉइंट्स. व्हाई इट इज ए कैपेसिटर, लॉजिकली ऑसिलेटरी, एंड हियर आल्सो पावर सेम, करंट का मैग्नीट्यूड सेम होना चाहिए, डायरेक्शन उल्टा भी हो सकते हैं. सो +1 और -1 भी हो सकते हैं. ठीक है, दैट इज द दोस सिंपल अंडरस्टैंडिंग कैन सॉल्व द क्वेश्चन इजीली. राइट, चलो लेट्स डू द नेक्स्ट क्वेश्चन. So give a try for this question. Please give a try. It's a good question. here switch is closed for a long time, opened at 0. It's a RLC circuit, resistor high inductor capacitor, second order perfect circuit. You need to find the response IL of t. It will take time, but give a try. Try it. Okay, I'll do it. So few seconds more, 7 seconds more. Let's see what is the option. नीचे जाओ मैं, ठीक. Here you can see all the options are in the same format. What is that format, sir? E power minus alpha t k1 cos beta t plus k2 sin beta t. Undoubtedly, it's a second order system, and this is the response we get, maybe what we call underdamped kind of response you are getting here, and no doubt. So but क्या हुआ ना, सारे ऑप्शन सेम ही फॉर्मेट में है ना, सो हम इस क्वेश्चन पे क्या कर सकते हैं, यू कैन ट्राई बाय यूजिंग व्हाट वी कॉल, you can give a trial by eliminating the options. You can try the question by Laplace. How to try it by Laplace, sir? Switch को open करो, inductor को SL से replace करो, capacitor को 1 by SC से replace करो with the initial currents or voltages, whatever it might be, and find IL of S. It will take some time. It will take more time to solve it, but here relatively less time पे कर सकते हैं. इस केस में substitute t equal to 0 plus. What is the answer? E power 0 तो 1 होता है ना, cos t तो 1, sin t तो 0. This will be 2. This will be minus 4. This will be minus 4. Which option suits my network? Firstly, at time t equal to 0 minus, independent source connected to the network for a long time, network is in steady state. Okay. Steady state में मैं क्या करना, मेरा कैपेसिटर जी को ओपन करो, इंडक्टर जी को शॉर्ट करो, ठीक है. Right. ठीक है. ये आपने करंट डिवीजन प्रिंसिपल अप्लाई किया तो ये तो 4 एम्पियर होता है, 2 एम्पियर, 1 एम्पियर. ये कैलकुलेशन बहुत बेसिक क्वेश्चन है ना, टोटल इनटू दैट पर्टिकुलर एडमिटेंस पे टोटल नहीं है तो 2 पैरेलल विथ 4 पैरेलल विथ 8 is 8 by 4 पैरेलल विथ 8 by 2 पैरेलल विथ 8 by 1 ना, इट विल बी 8 by 7. ओके, सो 3 रेजिस्टर्स तो 8 by 7 होता है, करंट तो 7 है ना. What is the drop? What is the voltage drop you get? 7 close, 8 volts na. So take here 8 volts, 8 by 4 to 2. Here, so 8 by 2 to 4, 8 by 4 to, like this you can do it. Okay. So our current division principle, कुछ भी करो यार, ये तो basic वाला चीज है. So आपका VC of 0 minus कितना? It is 8, it is equal to VC of 0 plus. Similarly, IL of 0 minus कितना, it will be, ये करंट 4 है तो ये कितना -4 है ना, सो -4 वाला रखना चाहिए, 2 वाला तो हटा दो, दो ऑप्शंस तो गया भाई, और दो ऑप्शन आपके पास है। समटाइम्स अनफॉर्चुनेट हो सकते, चारों ऑप्शंस में एक ही ऑप्शन भी एलिमिनेट नहीं कर सकते, उस समय पे कुछ नहीं कर सकते, हमने क्या करना, लैप्लास से पूरा प्रॉब्लम सॉल्व करना चाहिए, बट बहुत टाइम तो लगेगा। बट इस केस में व्हाट हैपेंस हियर, हियर दीज टू आर द ऑप्शंस अवेलेबल, सो ये दोनों पे एक सही होता है, हम ये इसको ऑब्टेन करना चाहिए। इसके लिए IL ऑफ 0 प्लस से दो ऑप्शंस में, एक जनरली डिफरेंशियल इक्वेशन सॉल्व करने समय पे भी K1 K2 हम कैसा निकलते हैं भाई, you can understand because here alpha तो पता है, बीटा तो पता है, don't solve the problem, K1 K2 ही चाहिए मेरे को। K1 के लिए मैं तो टाइम t इक्वल टू 0 सब्स्टिट्यूट किया, ये साइन हटा दिया, कॉस हटा दिया, K1 डायरेक्टली आया। सिमिलरली K2 चाहिए तो हम क्या करना चाहिए, K1 को एलिमिनेट करना चाहिए, और बाकी पार्ट को एलिमिनेट करने के लिए ये कॉस को साइन पे कन्वर्ट और साइन को कॉस में कन्वर्ट करने के लिए मैं क्या करता हूँ, डी बाई डी टी करता हूँ, ठीक है। So initial value से ही निकलते ना, what you do generally in the differential equation, same चीज, so d by dt of I of t find out करना चाहिए, ठीक। So now listen here, just a moment, let's move to the next page। okay, कोई भी दिक्कत नहीं, ठीक है। So this is what we discussed। Oh, very good। So now see here, हम क्या करते हैं अभी, आपको पता है IL of 0 plus equal to -4, ठीक है। What is DIL by dt? आपको पता है L di by dt equal to voltage across the inductor. Then what is DIL by dt? It is VL by L. So we need to find, draw the circuit at time t equal to 0 plus first. T equal to 0 plus में क्या होता है सर, इस सर्क्यूट का t equal to 0 plus में ये सोर्स तो हटा दो, ठीक है, ये सोर्स तो हटा दिया मैंने, now capacitor voltage source series with a short circuit, voltage source का initial voltage कितना भाई, कैपेसिटर का initial voltage 8, इंडक्टर तो current source of -4, and this is your VL of 0 plus, this will be -4, this will be +4, 4 8 how much, 32, then loop equation बनाओ, VL of 0 plus कितना आएगा, 40, then what is DIL by dt, VL of 0 plus by L, that is 40 by 4, that will be 10 amperes per second. So हम क्या करना, ये दोनों ऑप्शन में d by dt करके, which one will give you 4, that will be your answer, which one will not give you 4, that will be your wrong answer. So let's do this part। So let me do that. ऑप्शन सी क्या? ऑप्शन सी e power minus 2t 3 sin t minus 4 cos t. ऑप्शन डी e power minus 2t 2 sin t minus 4 cos t. ठीक है, इसको इसमें क्या होता है सर? व्हाट इज डी बाई डी टी एट टाइम t इक्वल टू 0? ओके, सो निकाल दो u into that is minus 2 e power minus 2t into डायरेक्टली में सब्स्टिट्यूट कर सकते हैं ना, 3 into 0 minus 4 into 1, इसको भी 0 कर रहे हैं डायरेक्ट, प्लस e power minus 2t into d by dt of this 3 cos t plus 4 sin t. इसको ये पार्ट तो 0 हो जाएगा, ये पार्ट तो 1. डायरेक्ट सब्स्टिट्यूट कर रहा हूँ, ये बेसिक वाला चीज है ना, राइट? बिकॉज ये तो 3 sin t minus 4 cos t. So it is minus 2 into minus 4 plus 3, because ये तो 1 होता है ना, सब्स्टिट्यूट t equal to, it will be 11, which is wrong answer. So automatically D is the right answer. No need to calculate. But हमारा satisfaction के लिए आप calculate किया तो this will be minus 2 e power minus 2t into 2 sin t minus 4 cos t plus e power minus 2t. Okay, 2 cos t plus 4 sin t. Substitute t equal to 0. So minus 2 into 2 into 0 minus 4 plus 1 into 2 plus 0. So 8 plus 2, 10. Okay, fine. So this is the right answer. Sir, conventionally कैसा करना सर इस वाले questions को? Listen, at least I should show you. Okay, here मैं तो options eliminate करके कर लिया, but conventionally करना चाहिए for t greater than equal to 0. This circuit में क्या होता है सर? We should replace the network with its Laplace equivalent. So एक रेसिस्टर है 2 फैरेड का, कैपेसिटर को हम क्या करना, V naught by S in series with 1 by SC. Inductor, you may replace L I naught. L in this direction minus 4, no, minus 4 into minus 4, 16 in series with 4S. Or you can also take SL parallel with I naught, but this is the simple circuit, no? That's why I have taken this. You need to find this item. Okay. Normal node analysis से निकल सकते हैं, ठीक है? If you take this as VC by 2, VC minus 8 by S by 4 by S plus VC minus of minus plus 16 by 4S plus 8 equal to 0. आप पूरा सॉल्व करके VC निकालो. After that you can find I of S. Okay, I of S equal to VC plus 16 by 4S plus 8. ये तो घर पे सॉल्व करके चेक करो, आपको 100% सेम आंसर आएगा. ठीक है, थोड़ा सा आपको लैपलेस ट्रांसफॉर्म सही से आना चाहिए. ओके, Shall we proceed for the next? So this is how you need to solve the RLC circuits here. Okay, give a try for this question. Just a moment. Try this. Option B. Okay, fine. So firstly, let's understand the formulas for this. Very important formula given in exam many number of times. What is voltage across the inductor? L dIL by dt. Current in the capacitor? C dVc by dt. So what is dIL by dt? VL by L. What is dVc by dt? IC by C. Now, what is d square IL by dt square? It can be d by dt of dIL by dt. So d by dt of, what is dIL by dt? dIL by dt, VL by L. So VL into 1 by L. So what is d square Vc by dt square? D by dt of dVc by dt. That will be, what is Vc? IC by C now. So 1 by C d IC by dt. Okay. So you have the standard formulas only for this. और कोई भी d by dt आपको चाहिए तो हम क्या करना चाहिए भाई? If you want any other d by dt, we need to find by using the KCL and KVL. You need to find the relation. For example, we will do this question. I will explain that. So the switch is in the position 1. For a long time and it is moved to position 2 at time t equal to 0. Find d square IL by dt square. Okay. Where is I यार? I तो देना चाहिए. Okay. Because you have a RLC circuit. Any I is same ना. मैं तो यही पे ले रहा हूँ. अगर डायरेक्शन चेंज किया तो आपका आंसर भी चेंज होता है. No doubt in it. नहीं तो यही पे ले लो. It is your convenience. Printing mistake तो मैंने नहीं देखा. Okay, listen. Firstly, find the response at time t equal to 0 minus. You can do different ways. एक method तो ये होता है RLC network का I निकल के okay, you can find the response, but that is wrong way. Gate aspirate, that is for before 0. He asked after 0 na, it will not be same. Okay. Now see here, the switch is at the position 1. A switch is at the position 1. Okay, at that time RL circuit का current response निकल सकते हैं. Time t equal to 0 minus, but independent sources network is in steady state. So आपका 10 volts तो connect किया, ये तो 1 K inductor acts as a short circuit. So 10 by 1 K, 10 milliamp. Okay, right. Now see here. Now what happens at time t equal to 0 plus? T equal to 0 plus. I have connected a capacitor, a resistor, and inductor. Source तो हटा दिया. Capacitor G acts as an open circuit because it is not having any initial value. Inductor G acts as a current source parallel with the open circuit. What is the current source value? 10 milliampere. And this is IL of 0 plus, VC of 0 plus, VL of 0 plus. ठीक है. Now you take this as V out. Firstly, listen here. If you take this current as IR, can I say, I'll move it. Can I say here, IR is equal to IL? Okay. So can I say DIR by dt is equal to DIL by dt? Yes, sir. Yes or no? Then it is equal to same. What is VL by dt? VL of 0 plus by n is my DIL by dt. So VL of 0 plus कितना इस क्वेश्चन पे? ये 10 मिली एम्पियर यहीं से आएंगे तो 10 into 1K, 10 volt आएगा. This is 0. Okay, it is just acts like a short circuit. Okay, so this what is VL of 0 plus? Minus 10 by L value कितना? L value 2. So that will be minus 5 amperes per second. So this is minus 5 amperes per second. Similarly, what is dVC by dt? IC of 0 plus by C. But current in the capacitor you should not take in this direction. Always you should take positive to negative. So IC of 0 plus तो उल्टा direction है ना. So minus 10 milliampere by capacitor value कितना दिया? 1 microfarad. So minus 10 power 4. Okay, right. So here DIR by dt मिला. What is the voltage across the resistor? R into IR. Okay. So what is dVR by dt? R into DIR by dt. Okay. R value कितना? R value तो 1000 into minus 5. That is minus 5000 amperes per second. Okay. Now this is minus 10,000 volts per second. Here also volts per second. So firstly, now tell me why I am doing all these things. I'll explain. Listen here. What is your VL of 0? What is VC of 0 plus here? It is VR of 0 plus plus VL of 0 plus. Then what is my VL of 0 plus? VC of 0 plus minus VR of 0 plus. Then what is dVL by dt? It is dVC by dt minus dVR by dt. ये करने के लिए मैंने इतना किया. So dVC by dt आपके पास है ना, minus 10,000 minus of minus plus 5,000. It will give you minus 5,000 volts per second. Now examiner को क्या चाहिए? d square IL by dt square. What is d square I by dt square? dVL by dt into 1 by. So minus 5,000 by minus 2,500. Okay, ampere per second square. That is the answer. Here very important. आप इस इक्वेशन लूप इक्वेशन में VC का जगह पे जीरो डाल दो, dVC by dt तो जीरो हो जाएगा, आपका आंसर तो गलत हो जाएगा. So इन क्वेश्चन पे ये तो मोस्ट कॉमन मिस्टेक होता है. Any time when you take the loop equation, never take the constant value. Here also IR equal to 10 मत ले लो. Okay, directly इसका वैल्यू लेके d by dt को जीरो मत करना. ठीक है, it's a value at that instant, it is not constant. So never take the loop equation में the value, you should take the variable only into consideration. Okay, this is very important, right? No, your method is correct before zero, but after zero, the response is not exponential, na? RLC circuit में how the response is exponential. After zero, the response is RLC में oscillatory होता है ना? आप ऐसा भी कर सकते हैं यार, पूरा रेस्पॉन्स निकाल के डी स्क्वायर बाई डी टी स्क्वायर 2 टाइम्स कर सकते हैं, आपको आंसर तो मिलेगा. ओके, विच एवर यू फील कन्वीनियंट यू कैन गो बाई इट. सो इज इट क्लियर हाउ टू फाइंड और हाउ टू डील विद द डी बाई डी टी? Before and after d by dt compulsory changes. Current only does not, current ka magnitude doesn't change. Suppose if it is charging, if it is discharging, d by dt changes, its value may not change at this instant. Okay, so some people are saying sir I of 0 minus equal to I of 0 plus, so can I say d by dt of 0 minus is equal to d by dt of 0 plus? Wrong. Okay, that you cannot take. Up to 0 it may be charging, after that it is discharging, or up to 0 it is charging with one time constant, then another time constant आया. So जैसा कुछ भी हो सकते हैं यार, because of the switching action its value may not change, but the rate of change will be changing. Okay, चलो let's move further. It's no voltage sign will remain same, voltage ka value will be reverse. You understand? Here the sign we take is always same. As a standard we follow positive to negative only, but after zero what happens? Inductor starts delivering the energy. When it is delivering the energy, current direction should be negative to positive. Inductor current cannot change, so voltage polarity उल्टा हो जाएगा. Charge or discharge वाला concept. Okay, so up to zero, because the source is present, inductor is charging. Okay, every time we don't know whether it is charging or discharging and confused with the polarity. Every time we take the current from positive to negative only. But here we got negative, it is indicating that you assume this is absorbing, but your assumption is wrong. It is delivering the energy after zero. Why? Because this energy stored will be given in this direction. Then at zero plus, it is giving the energy. So current will remain same, voltage polarities will be reversed. That happens for inductor. For capacitor, generally, if it is having some initial energy, its voltage polarity remains same, current direction will change. Right? Chalo, next. So for the circuit shown in the figure, the switch is ये सभी questions तो आप लोग कर सकते हैं. Okay, let's do this question also. हाँ ये तो नहीं चाहिए. Try this question. It's a very good question. Please give it a try. Give it a try. Any answer? Yeah, read the question. There is some microprocessor based control measurement scheme shown in the figure. Where here Rx is the unknown resistance. You want to know the resistance Rx. Okay, while uh, R reference and C reference, you know it already. Uh, C reference is charged from VL to VH by a DC constant voltage source. So this is having initial voltage of VL. Now it is charged to VH by using that what we call C reference and R reference. And once through R reference, and it takes how much time? T reference times. And then it is discharged to VL again, and it is again charged from VL to VH through RX in TX seconds. And there is a relation between Rx and Tx and T reference. By using this relation, out of these options, you need to select one for the value of Rx. You need to find the unknown. So here, don't worry about this part. ये माइक्रोप्रोसेसर कहाँ से सेंस कर रहा है डिस्टेंस को एंड हाउ इट इज डूइंग दिस जॉब, इट डजंट मैटर फॉर अस. आपको ये पार्ट में जो इंफॉर्मेशन एग्जामिनर दिया ना, दैट इज सफिशिएंट. सो फर्स्ट केस में what is your tau 1? Tau 1 is equal to R reference into C reference. Okay, now it is charged from VL to VH. So what is your V of t? Through the voltage source, what we call Vs. So what is the final value here? Very good question. What is the final value here? Tell me. What is the final value? Tell me the final value क्या है यही पे. What is the formula of final plus initial e power minus t by tau? So final plus initial minus final e power minus t by tau पे final value क्या? Final value क्या बताओ? Please tell me what is the final value here. Final value कितना होता है sir? It is charging from VL to VH. It is charging from VL to VH. What is the final value? What is the final value? VH? नहीं भाई. Actually, here the final value is the value you reach at the steady state, not in the middle. So final value तो VS होता है यहीं पे. What is the final value here? VS. So final value plus initially it is having VL minus final value e power minus t by tau 1. Now at a time t equal to what is that? T reference. What is your VC? It is equal to VH. That is Vs plus VL minus Vs e power minus at what time? T reference by tau 1. Understand what I am saying? Capacitor voltage reaches VH at what time? T equal to tau T1. What is that? T reference. What is that? T reference is given by T reference is the time given by examiner. Similarly, second case क्या? Tau 2 is equal to Rx into capacitor remains the same here also. Okay. Then what is your VC? Here also same formula. Vs plus VL minus Vs e power minus t by tau 2 at a t equal to Tx. Okay. What is the value? At t equal to Tx, Vc will be equal to Vh. VL minus, sorry. That is equal to Vs plus VL minus Vs e power minus Tx by tau. Okay. Both are VH now, you can equate. He has given that Tx is equal to K times T reference. I'll use it later, just leave it. Okay. Now equate both of them. Vs plus VL minus Vs e power minus T reference by tau 1 is equal to Vs plus VL minus Vs e power Tx by tau. Here these two cancels. After that you can cancel this also. So you can say T reference by tau 1. What is tau 1? Tau 1 is equal to R reference into C reference is equal to Tx by tau 2. Tau 2 is how much? Tau 2 is equal to Rx into C reference. Again C तो cancel हो जाएगा. So आपका Rx क्या होता है सर? Rx is equal to R reference into Tx by T reference. So R reference into Tx by T reference. What is Tx by T reference कितना? Okay. So this is the answer. What is the Rx value is K times R reference. Option C. Okay. Question looks complex, but once you start now, it is not at all difficult. Okay. final value is the value you reach at a time t equal to infinity. Okay, and we have not analyzed the question at any point of discharging. We analyze the question when it is charging from VL to VH. After that, it discharged and again charged from VL to VH. The discharged part we haven't analyzed at all. Okay, so the question pay what he did, he charged with initial value VL to VH. Okay. If you leave this circuit up to infinity, it will reach VS. That is what here we have taken. And it will charge from VL to VH. The same, after that, what we have done, this is a discharge to VL and now connected to this circuit. So the discharged part you need not analyze at all. Chalo, next question. Try this question. So give a try for this question. So वाइलेशन ऑफ केसीएल केवीएल आएंगे तो इम्पल्स आएगा, कोई दिक्कत नहीं. So switch तो जीरो पे ओपन किया. Okay, switch is closed means initial current is this one. Now see here, always try this by Laplace, because if you open circuit this 3 will come and open circuit entering will be 3, leaving will be 0. Violation of KCL, impulsive condition. Impulsive condition में response हमेशा it is better to do by Laplace transform. So here firstly inductor का equivalent निकालो. एरो डायरेक्शन से नेगेटिव टू पॉजिटिव लेना चाहिए. एरो ऐसा है ना, L into I naught. Okay, and series with SL. Similarly here, simply SL because no initial value. Okay, see here. So what is this current I of S? It will be 3 by S plus 2S. Okay. So it will be 3 by 3S. That will be 1 by S. So what is your I of t? It is 1 ampere for t greater than equal to 0. आपको इम्पल्स देखना चाहिए तो देखो, ये वोल्टेज निकालो. What is V of S? I of S into 2s. I of s kitna? 1 by s into 2s. That will give me 2. What is v of t? 2 times del of t. कैपेसिटर instantaneously charge हुआ तो undoubtedly impulse तो 100% आएगा. This is the instantaneous charging of the capacitor. Okay, sorry, inductor, capacitor, inductor, whatever. Okay, if you want to know, this is just for understanding. No need to do this. Okay, there is one formula also here. It is L1. One minute. L1 I1 plus L2 I2 by I1 plus I2 is the steady state value. L1 kitna here? 1. I1 3. L2 2. I2 0. 3 plus 0. That will be 3 by 3. Okay. Here direction is important. This is the I1 direction and this must be I2 direction. Okay. नहीं है, these are the initial values. Okay. अगर उल्टा है तो माइनस हो जाएगा. Same value, same happens for capacitor also. I1 of C1 V1 plus C2 V2 by C1 plus C2. So L1 plus L2 होता है L1 I1 plus L2 I2 by L1 plus L1 plus L2 क्या 1 plus right C1 V1 plus C2 V2 by C1 plus C2. Same way L1 I1 plus L2 I2 by. Yes. Let's go for the next. Let's do the next question. Yeah, try this question. This is also instantaneous charging of the capacitor. Okay, these are not second order circuits. Some special cases also have included. So give a try. Okay, stop. You have 1 farad capacitor with the initial voltage of -1. So capacitor with the initial voltage of -1. Okay, 1 farad is connected across the ideal voltage source of 1 volt. Across the ideal voltage source if 1 volt. Okay, determine the energy delivered. Okay, so what is Vc of infinity? When you connect like this, it will charge to 1. What is VC of 0 minus 1? What is energy initially before infinity? I mean at infinity, half C V square 1 by 2. What is the energy initially capacitor is having? Minus 1 square V 1 by 2. So what is the net energy? So can I say 0 is the answer? Wrong answer. Can I say 0 joules energy is delivered by the source? No, नहीं. क्योंकि देखो मेरा कैपेसिटर का वोल्टेज तो -1 पे है. I have charged this and bring it to +1. So to do some work, आपको energy तो चाहिए ना, compulsory. And so there will be some energy. This is the condition where you cannot solve the question by law of conservation of energy, or you can say impulsive condition occurs. Here what happens? The impulsive condition occurs due to law of what we call violation of KVL condition. Always in this kind of problems, we should solve by Laplace transform approach. Okay. So because the capacitor is getting charged instantaneously. So how to solve it? Capacitor to source is 1 by S. Capacitor का Laplace equivalent V naught by S 1 by SC. What is I of S? 1 by S minus of minus plus 1 by S minus. So 2 by S by 1 by S will give me 2. What is my I of t? 2 times delta. Okay. So what is the voltage V of t? Voltage तो 1 है ना, because this is 1. Okay. What is the energy? Integration of 0 to infinity voltage V into current I. So 0 to infinity is 1 into 2 del of t. What is the integration of delta? Right. So this will give me energy of 2 joules. Okay. So don't apply this formula. This will be wrong. Suppose, see here. If capacitor is having some initial voltage V1, you are connecting to the source V2. Okay. What is the energy supplied is given by here current I of S equal to V2 minus V1 by S by 1 by SC. So C times V2 minus V1. Voltage is equal to V2. So energy is equal to C times V2 into V2 minus V1. By doing all integration, all the story, I am saying that. And this will give me I of t equal to. This is the impulse it will generate. So infinite current will flow through the what we call 0 ohm resistance, because you should get the doubt, sir. Other than capacitor, there is no element who takes this energy. Yes, because that will be so. It is at this point of closing the switch, you can see the spark. Okay, so the energy will be dissipated from this wire. Even when you have a 0 ohm resistor, if it is a finite current, there will not be any energy dissipation. But if it is an infinite amount of current, which can satisfy your what we call the law of conservation of energy. Okay. Chalo, let's move for the next. So this is about the instantaneous charging of the inductor and the capacitor wala concept. We will go for linear charging also. Agar time high. See here, multiple switches wala concept there only. Okay. If switch closed at t equal to t naught. Find response assuming t equal to 0 and replace t with t minus t naught in the final response. Okay, so this is the trick you can do, or you can go by Laplace time shifting property. ठीक है. दूसरा, if this sort of pulse is given as the input, if pulse given as input, okay, what to do? Assume input equal to DC, solve, find response at t naught minus. After t naught, treat as, I'll do it, okay, one problem, you will get source free. This is what you need to do. After t naught, you should assume it as a source free and solve the question. Next, यही तक सही है ना? चलो, okay. I'll show you one example. So इस question का this pulse is there ना? You can write it as a into u of t minus u of t minus t. इसका Laplace transform a by s into a by s into e power minus s, because x of t का Laplace transform x of s है, तो टाइम शिफ्टिंग प्रॉपर्टी में x of t minus t naught का क्या होता है सर? e power minus st naught into x of s. We use this, or directly you can do. Say for example, you have a 1 volt source. You close the switch at a time equal to 5 seconds. You have 1 ohm, 1 Henry. Okay. I need to find I of t for t greater than equal to 5. There are two methods. One method is assume switch closed at t equal to 0 only. Okay. Okay. Then what is IL of infinity? 1. What is tau? 1. What is the formula of IL of t? 1 minus e power minus t by tau into final value. Now replace t with t minus 5. हो गया question. That's all. नहीं है तो आप ऐसा भी कर सकते हैं. Your input is equal to u of t minus 5. इसका लैपलेस ट्रांसफॉर्म e पावर माइनस 5s by s. इस केस में आप e पावर माइनस 5s by s लेके ऐसा भी कर सकते हैं. तो i of s क्या होता है सर? e पावर माइनस 5s by s into s plus 1. So e power minus 5s common ले सकते हैं 1 by s minus s plus 1. So that will give me same u of t minus 5 minus e power t minus 5 into u of t minus 5. The same answer. This is for t greater than equal to 5. Normal is for t greater than equal to 0, na? Okay, this we convert like this. Okay, this is how you deal if the switch is closed in between. Now let's do a pulse question. Try this. Okay. Okay. Two more questions are there. I'll finish it off and I'll leave the class. So here, 3 volts DC. I mean, here what to do? Pulse is given as the input. Na? First, time, assume DC. सर्क्यूट को पता नहीं ना, इट इज गोइंग टू स्टॉप एट 0, स्टॉप एट 2 सेकंड्स. इफ डीसी इज अप्लाइड, नॉर्मली आपको डीसी में क्या रेस्पॉन्स मिलेगा, सेम रेस्पॉन्स मिलेगा यहीं पे भी. सो एज्यूम डीसी vc ऑफ इंफिनिटी आप 3 एज्यूम करो, मे बी सडनली इट इज डिस्टर्ब्ड, बट इफ इट इज केप्ट अप टू इंफिनिटी इट इज 3 एंड vc ऑफ 3 है. तो व्हाट इज योर, ये तो नेग्लेक्ट कर सकते, छोड़ दो. एंड व्हाट इज योर टाउ, 10 power minus 7 into 10 power 3, 10 power minus 4. So 1 minus e power minus 10 power 4t into the final value 3. This is your VC of t. Then VC of infinity हम assume कर सकते 3. Now find VC of 2 just before this switching action. What is the response? This, in this particular question, it is almost 3. Now, for d greater than or equal to 2, you should replace this with a short circuit. Source को short circuit करो, source free circuit ना, and capacitor का equivalent 1k. This is for VC. V naught तो minus VC होता है, वो calculate कर सकते हैं. So here, what is the voltage? 3, and this is 10 power minus. Okay. Source free circuit. So what is your VC? It is V naught e power minus t by tau. But t का जगह पे हम क्या लिखना? T minus 2 लिखना. So what is your V naught is minus VC minus 3 e power minus t by tau. T का जगह पे T minus tau लिखना. हो गया क्वेश्चन. So आपको एग्जामिनर को क्या चाहिए? At t equal to 2, it will be, what is its value? E power 0 तो 1 होता है ना. So if t equal to 2, your v naught equal to minus. आप डायरेक्टली भी ड्रा कर सकते हैं. t equal to 2 पे सोर्स तो शॉर्ट सर्किट हो जाएंगे, कैपेसिटर, एंड minus 3 डायरेक्टली बोल सकते हैं. But to give you the concept properly, I have done all this. So replace t with t minus t naught. T naught is the point where you are making the pulse to 0. Okay. So this is how you deal with the multiple switching conditions. Okay. That you can neglect, it is of no meaning. DC पे ये माइनस J2 कहाँ से आएगा, तो प्रिंटिंग मिस्टेक. ठीक है, चलो. Last concept, last questions, last two questions. एक्चुअली ये सारे क्वेश्चंस करना चाहिए, उतना टाइम तो नहीं अवेलेबल. यू ट्राई दिस एज अ होम. आपको नोट्स मिलेगा मेरा टेलीग्राम चैनल पे, शंकर पे, t.me shankar23 is the link. Okay, this is my telegram channel. Okay, से करंट सोर्स सीरीज में है तो सपोज करंट सोर्स इज इन सीरीज. Okay, say what is your v? 1 by c integral I dt. So it is I by c into t. Okay, it is even it is a RC circuit also. Normal, if it is a series circuit में, if you know the current, you know everything because series में current same. Normal KCL KVL से you can find the response. Similarly, parallel circuit में आपको पता है voltage. For example, okay, this is your V. What is your I? Is integration of 1 by L V dt. That is V by L into T. Ramp signal आएगा, linear charging वाला condition है. So let's take this and solve the question. This question maybe you have studied in your what we call power electronics. Some converter होता है, इसमें direct formula भी है, but अभी तो हम network analysis use करके solve करेगा. So in the network shown in the figure, switch is operated at a frequency of 10 kHz. वो switch थोड़ा on off तो 10 kHz से होगा to generate this kind of triangular waveform. Okay, as shown. Determine the value of IP and T on. So let's do this question. So firstly, what is the on and off time together? Time period is equal to 1 by 10 power 4, 100 microseconds. That is T on plus T off together. This is off time and on time together. Okay, fine. So when the switch is on, what is the condition? Switch on है तो ये 100 volts, inductor across can है 100 micro henry. ये तो 500 है. आप डायोड के बारे में बताओ. ये तो -500 पॉजिटिव को दिया, +100 नेगेटिव को दिया. डायोड क्या रिवर्स बायस हो जाए. This will be 100 and this is my current. What is my current here? 1 by L integration of, because I know the voltage across the inductor, directly I can apply the equation. 0 to कहाँ तक कर रहा है? Time t is equal to t on तक. ये switch तो close है. Voltage across the inductor 100 dt. So it will be 10 power 6 into t from 0 to t on. If you substitute t equal to t on, what is your I? It is reaching the value called IP. IP is equal to 10 power 6 times. I'll use it later. Now switch off वाला condition भी. Switch off पे now क्या हुआ? मेरा इंडक्टर को स्विच ऑफ का समय पे इंडक्टर इज हैविंग नाउ सम इनिशियल करंट IP. Okay, so this is -500. 1 minute, 1 minute. Okay, so inductor current cannot change instantaneously. The current will come here. It cannot go in this path because open circuit में current तो नहीं जा सकते. Infinite voltage चाहिए इसमें जाने के लिए. ऐसा आएगा current, ऐसा आएगा current, ऐसा आएगा current. So it will flow in this direction. So if current flows from positive to negative, the diode will be forward bias. अरे सर कैसे जाएगा सर? यही पे मैंने -500 दिया ना सर. Yes, The voltage across the inductor can be negative also na, while it is discharging. It will give you more than minus 500 and it will make it forward bias because it is not having any alternative. Yeah, more than minus 500 देके forward bias नहीं किया तो entering current not equal to leaving current, KCL will be violated. So it need to give in that case impulse infinite voltage. Instead of infinite, it can give easily minus 500. Okay. So what happens here is because it is giving the energy, some of VL can be negative initially and it can forward bias. Or when current is flowing from positive to negative, diode तो forward bias ही हो जाएगा. Here reverse bias होने के लिए chance ही नहीं है. So now what is your current IL, initial current plus, because अभी तो initial current है ना, plus 1 by L. L is 10 power minus 4. इंटीग्रेशन ऑफ कहाँ से कहाँ तक, कहाँ से कहाँ तक, बताओ कहाँ से, t on to total time t. Okay, what is its voltage now? Minus 500 t. So IL equal to 10 power 6 times t on. Okay, minus 5 into 10 power 4 and 10 power 2 is 6 into t from t on to t. But आपको पता है at t equal to capital T, your current is becoming 0. You see here, the current increases and decreases. Okay, that is given by examiner. You can see. ये तो 0 हो रहा है ना. Okay, so T on equal to 5t minus 5t on. 5t equal to 6 times t on. So आपका t on क्या होता है सर? 5 by 6 t. That will be 83.33 microseconds because t is 100 microseconds. And IP equal to 10 power 6 t on. That will give you 83.33 amperes. A question looks complex, but it is not at all complex here. It's not a second order circuit, but it's a special case of the linear charging of the inductor. Linear charging of inductor. Last time I told बताया exponential, linear and impulsive. Okay, instantaneous. So it's linear. Last question for today's class. Please go through this question and we can end the session for today. Yeah, please do this. I'm going to end the class. Just read this question. Okay, so see here, the circuit shown in the figure is used to charge the capacitor C alternatively from two sources. ये दोनों sources है भाई, एक बार ये, ठीक है? So looks complex but not difficult. The switch S1 is mechanically coupled and S2 are mechanically coupled. So first understand, for t greater than or equal to 2nt to less than n equal to 0 substitute. Okay, so S1 तो P1 पे connect किया. So this is the circuit. S2 to P2 को connect किया. So it is anyway disconnected. Don't worry about this part. So this is what happens. And what is this current? 1 ampere. You need to find Vc. 1 by C integral 0 to t 1 dt. That will be t. So at time t equal to, it's a ramp signal simply. At time t equal to capital T, what is your VC? It will reach T. So this is how it is reached. Okay, first part. Now, for t greater than or equal to 2n plus 1t to 2n plus 2t, n equal to 0, t greater than or equal to t to 2. Okay, so now see here. S1 is connected to Q1. Now S2 is connected to Q2. So capacitor is now having initial voltage of V0 equal to T 1 current. Now new switch is connected in this direction. Now you tell me what happens here. What is IC is minus 1. This is my VC. VC polarity given by exam. So what is your VC now? Initial value plus 1 by C integral T to 2T current IC dt. What is V0 value? T 1 by 1 integral T to 2T IC value minus 1 dt. So it is a T minus T from T to 2. This will be, already you have a waveform up to T now. Now from T to 2T, if you substitute T equal to 2T, your VC will become 0. Understand? Understand? So this is what it is generating. After that, you substitute n equal to 1, 2, 3, 4, 5, 6. So it will generate a waveform like this. इसका mathematical equation लिखो, signals and systems से your job is done. So all these comes under linear charging of the inductor and the capacitors. बहुत सारे मॉडल्स हैं मेरे पास. Every single model. Generally, if you attend my comprehensive course, I cover. Even in my comprehensive course of networks in YouTube also, you have all this kind of questions. Not same. This question you try as a homework. Okay, I will generally solve. My comprehensive course में है, नहीं तो मेरा Telegram channel पे आके पूछ लो, मैं देता हूँ answer. So that is about your today's session. We have done wonderful number of questions and very good quality questions today. Please kindly like this session, share this session to many number of your friends so that they will be able to learn, and we can get a more reach and we can give you more and more initiatives for you. Right, let's end the session for today. So न्यू बैच तो स्टार्ट हुआ भाई. आप अनअकैडमी का सब्सक्रिप्शन लेना चाहिए तो डोंट फॉरगेट द कोड फॉर द बेस्ट पॉसिबल क्लासेस एंड गाइडेंस शंकर 10. राइट, सो रैंक इंप्रूवमेंट बैच भी चल रहा है आप लोगों के लिए. आप 4 महीना सब्सक्रिप्शन भी ले सकते हैं अकॉर्डिंग टू योर कन्वीनियंस. सो एनी टाइम यू कैन यूज माय कोड शंकर 10. मैं डिजिटल भी शुरू कर रहा हूँ दिसंबर 8 से. ओके, so you can join an academy, compete, you can battle with 1-to-1. So all टेस्ट सीरीज 500 पे आपको मिल रहा है. इसमें भी आपको डिस्काउंट मिलेगा मेरा कोड यूज कर. राइट, सो दिस इज द टोटल टेस्ट सीरीज एंड अन अकेडमी लाइट का सब्सक्रिप्शन. सो 3 महीने है आपके पास. आप तो यू कैन टेक द सब्सक्रिप्शन विद जस्ट 3000 per month. You can take the 4-month subscription also. राइट, सो इफ यू टेक आइकॉनिक सब्सक्रिप्शन आपको फिजिकल नोट्स भी मिलेगा. ये सारे बेनिफिट्स ऑफ आइकॉनिक सब्सक्रिप्शन ऑफ अनअकैडमी. प्रिंटेड नोट्स, 1-to-1 मेंटरशिप, आपको पर्सनलाइज्ड गाइडेंस मिलेगा, स्ट्रेटजी सेशंस मिलेगा. बाकी तो टॉप एजुकेटर का क्लासेस, डिजिटल नोट्स, टेस्ट सीरीज, ऑल द क्वालिटी क्लासेस is available with Unacademy, is common for everybody, even for Plus and Iconic. Okay, so anytime you want to take the class, Unacademy subscription, you can use my code Shankar10. Okay, we have multiple educators for every single subject. You can choose your favorite educator and you can study. When you feel inconvenient with any particular, you can change it also according to your wish. It is, I mean, every educator will teach you the best, but it is your own choice. Thank you very much for your time, guys. See you all with few more classes next week or something. Okay, chalo, thank you.